Climate change is often described as global warming, but it is bigger than a rising temperature number. Global warming means Earth's average surface temperature is increasing. Climate change includes that warming plus the wider changes that follow: shifting rainfall, hotter heat waves, stronger extremes, melting ice, rising seas, stressed ecosystems, and new risks to human health and economies. Earth's climate has changed naturally over deep time, but the change happening now is different because of its speed and its main cause. Since the Industrial Revolution, human activity has rapidly increased the amount of heat-trapping gases in the atmosphere. The result is not just a warmer world, but a climate system being pushed out of the stable conditions in which modern civilization developed. The central driver of modern climate change is the burning of fossil fuels, coal, oil, and natural gas. These fuels powered factories, transportation, electricity systems, and modern industry, but burning them releases carbon dioxide. Deforestation adds to the problem because trees store carbon, and when forests are cut or burned, much of that carbon enters the air. Some agricultural and industrial practices release other greenhouse gases, including methane and nitrous oxide. These gases are called greenhouse gases because they affect how energy moves through the atmosphere. They do not stop sunlight from reaching Earth, but they do slow the escape of heat after the planet absorbs sunlight and radiates energy back toward space. The greenhouse effect is natural and necessary. Without it, Earth would be far colder and less suitable for life as we know it. The problem is that humans have strengthened this effect. Carbon dioxide is especially important because it remains in the atmosphere for a long time and accumulates as emissions continue. Today, the atmosphere contains roughly 50% more carbon dioxide than it did at the end of the pre-industrial era. These levels have not been seen for millions of years. That extra carbon dioxide acts like an added layer of insulation around the planet. More heat stays in the lower atmosphere, oceans absorb enormous amounts of energy, and the entire climate system begins to shift. One way to understand climate change is to picture Earth's energy balance. Sunlight comes in. Some energy is reflected by clouds, ice, and bright surfaces. The rest is absorbed by land and ocean, warming the planet. Earth then releases heat upward as infrared radiation. Greenhouse gases absorb part of that outgoing heat and re-radiate it, keeping the lower atmosphere warmer. When greenhouse gas concentrations rise, less energy escapes easily to space. The planet gains more heat than it loses. Even a small change in the global average temperature represents a huge amount of added energy. That energy does not spread evenly, which is why climate change appears as both gradual trends and disruptive extremes. The clearest signal is temperature. The first decades of the 21st century have already shown major climate impacts, and 2024 was the warmest year on record since regular tracking began in 1850, reaching about 1.60 degrees Celsius above pre-industrial levels. A global average increase may sound small, but it is not like turning up a room thermostat by a fraction. It changes the odds of extreme events. Heat waves become more frequent, more intense, and more dangerous. Hotter air can hold more moisture, which can intensify heavy rainfall in some regions while worsening drought in others. The warming baseline means weather systems now operate in a changed environment. Many visible impacts are already unfolding across the natural world. Heat waves and wildfires are becoming more common in many places, drying landscapes and increasing risks to communities. The Arctic is warming faster than the global average, a process called amplified warming. This contributes to thawing permafrost, retreating glaciers, and shrinking sea ice. When ice melts, darker ocean or land surfaces absorb more sunlight, which can accelerate local warming. Mountains are changing as snow and glaciers decline. Coral reefs are under stress from hotter and more acidic oceans. Species that evolved for specific temperature ranges are being forced to move, adapt quickly, or face extinction. The ocean is one of the biggest buffers in the climate system, but that buffering comes with consequences. Oceans absorb much of the extra heat trapped by greenhouse gases, which leads to ocean warming. Warmer water expands, contributing to sea level rise. Melting glaciers and ice sheets add still more water to the seas. Oceans also absorb carbon dioxide, and when carbon dioxide dissolves in seawater, it changes ocean chemistry, causing acidification. This makes life harder for organisms that build shells or skeletons from calcium carbonate, including corals and some plankton. Even if future warming is limited, ocean heating, acidification, and sea level rise will continue for centuries. Climate change is not only an environmental issue. It directly affects people. Increased flooding can damage homes, roads, farms, and water systems. Extreme heat can cause illness and death, especially for older adults, outdoor workers, children, and people without reliable cooling. Changes in rainfall and drought can reduce crop yields and strain water supplies. Warmer conditions can also influence the spread of some diseases by changing where insects and pathogens can survive. Economic losses can grow as disasters become more frequent or severe. In some regions, climate stress can contribute to migration and conflict, especially where food, water, and livelihoods are already under pressure. The risks are not shared equally. Poorer communities and countries often contributed only a small share of global emissions, yet they are among the most vulnerable. They may live in more exposed areas, depend more directly on climate-sensitive farming or fishing, and have fewer resources for protection, recovery, or relocation. Wealthier communities can often build flood defenses, improve infrastructure, insure property, or adapt food systems more easily. This creates a climate justice problem. Those least responsible can face the harshest consequences. The World Health Organization has called climate change one of the biggest threats to global health in the 21st century because it multiplies risks across health, food, water, and safety. Another concern is tipping points. A tipping point is a threshold where a system can shift into a new state, sometimes in ways that are difficult to reverse on human timescales. For example, enough warming could contribute to the long-term loss of the Greenland ice sheet, which would greatly raise sea levels over time. Thawing permafrost can release additional greenhouse gases, adding more warming pressure. Coral reef systems can collapse when repeated heat stress becomes too intense. These processes do not all happen instantly, but the danger is that additional warming increases the chance of crossing thresholds. Limiting warming reduces the risk of triggering the most severe changes. The world has already recognized the need to limit warming. Under the 2015 Paris Agreement, nations agreed to keep global warming well under 2 degrees Celsius and to pursue efforts to limit it to 1.5 degrees Celsius. The difference between these temperature levels matters. Each fraction of a degree increases the likelihood of heat extremes, ecosystem losses, sea level impacts, and adaptation challenges. But current national pledges are not yet enough. Based on existing commitments, global warming could still reach about 2.8 degrees Celsius by the end of the century. That gap shows why climate policy is not only about setting targets. It is about rapidly changing energy, land use, industry, transportation, and finance. The main solution is to stop adding carbon dioxide to the atmosphere faster than nature and technology can remove it. That means phasing out fossil fuels by ending subsidies, conserving energy, improving efficiency, and switching to low-carbon energy sources such as wind, solar, hydro, and nuclear power. Clean electricity can replace fossil fuels in transportation through electric vehicles, in buildings through heat pumps, and in industry through electrification and cleaner processes. Some carbon can also be removed by restoring forests, protecting ecosystems, and using farming methods that store more carbon in soils. Adaptation remains essential, with flood controls, heat planning, water management, and drought-resistant crops. The future is not fixed, but the choices made now determine how much warming and damage can still be avoided. If you found this helpful, please like this video and subscribe for more explainers.